Chapter 2. Chapter 2 is going to be the starting of organic compounds. It's the nature of organic molecules. So we're going to talk quite a bit about simple molecules called alkanes, as well as the functional groups that we deal with in organic chemistry. One of the things in organic chemistry, I probably mentioned this before, is that there's pretty much an infinite number of molecules that you can create or are in our planets. Your book says there's approximately 37 million known organic compounds. That obviously is a lot. All right, and again, you remember we've talked about there are natural products or natural compounds found in nature, and then there's synthetic. All right, and remember that the synthetic could be a natural compound that's been synthesized, or it could be completely non-natural. Most of these are like the polymers that we talked about, plastics, things like that. And these compounds are broken down into something called families. This is what your book has this term. Most people call them functional groups. So it's not, you have all these compounds, you have to somehow organize them in some sort of groups. And these functional groups give molecules their characteristic chemical and physical behaviors. So section 2.1 is all about functional groups. What functional groups are, I'm going to go over them. I'm going to draw them out just to kind of give you an idea of what the functional groups are. The ones that I want you to know, these are types of groups that I want you to memorize. The best way to memorize them is to put them on a flashcard. Put the name on one side of the flashcard and put the actual functional group on the other side. So a definition of a functional group, and I'll kind of give you examples of why it's important, is it's a group of atoms within a molecule that gives its characteristic chemical and physical behavior. All right, so let me give you a few examples. One example, just to kind of give you an idea of what a functional group is and how just by slightly altering the functional group of a molecule, you can have completely changed chemical and physical behaviors of the molecule. All right, the first one I'm going to talk about is an alcohol functional group. I'll talk more about what the functional groups are, but I just want to give you an idea of why it's important. All right, alcohol, I'll use the most common alcohol, which is ethanol. I'll draw out the structure for you. It's a 2-carbon chain, which we will talk more about this in this chapter. And you have an oxygen with a hydrogen. Your oxygen, remember, has 2 lone pairs. So this is called ethanol or ethyl alcohol. All right, or ethyl alcohol. That's a common name. We'll talk about naming this chapter. Okay, but what the functional group is it's this oxygen, all right, attached to this hydrogen, and the oxygen is attached onto a carbon. So that is the a generic form of an alcohol. It doesn't really matter what's really attached at the points here. You could have other carbons or other hydrogens there. But again, we'll talk about that more in a bit. I just want to kind of show you the importance of it. The other type of functional group that I'll talk about right now is called a carboxylic acid. Carboxylic acid. All right, and the carboxylic acid, the one that I'm going to show you, is acetic acid. Acetic acid, you might know what acetic acid is. Let me first draw it out. and just kind of show you what the difference, not much of a difference. This compound is acetic acid. All right, the common name for this is vinegar. You all know what vinegar is. All right, and the functional group for a carboxylic acid is, as you can see, it's a carbon with a double bond oxygen attached to an OH, and then this carbon attached to the carbonyl is attached to another carbon. And then it doesn't really matter what that carbon's attached to, so at these spots you can have other hydrogens or carbons. But this functional group right here is considered the carboxylic acid functional group. So notice that the difference between the two is not that much. Okay, they both have this OH group, but the carboxylic acid has a C with a double bond oxygen attached to it, where the equivalent carbon over here is just a carbon that has two hydrogens. Okay, now notice these are the functional groups. You have the carboxylic acid functional group right here, and then you have the alcohol functional group. Okay, not that much of a difference. However, there is quite a bit of a difference between ethanol. All right, ethanol is the alcohol that is an alcohol that you drink, and carboxylic acid, and acetic acid is vinegar, which is, which you put on salads. Okay, so again, just a slight change. The family, the characteristics is way different. Like for dinner, I'll have like a beer or wine, and I'll drink that with dinner. And on my salad for dinner, I'll put on a little bit of the acetic acid and some oil. Okay, acetic acid goes very well on my salad. However, pouring a shot of vodka on my salad doesn't taste that good. Okay, and obviously, if I take a shot of acetic acid, that would not be a smart thing to do. All right, so I'm kind of like making a joke, but the whole point is just by changing one small group, by changing the functional group, you change the chemical and the physical behaviors of the molecule. Okay, and we're going to learn a whole bunch of different functional groups that are very important to recognize what kind of molecule it is. All right, so let's go over the different functional groups. There is, if you look on page, I believe it's 40 and 41, so page 40 to 41, you can also look on the front cover of the book. And you will see all of the functional groups. All right. What I'm going to do is I'm going to go over the functional groups that I want you to know. I don't want you to know all of them. I'm going to go over them. I might change the names and just kind of show you, how they're trying to show you what the functional groups are. Occasionally, it kind of looks a little confusing. All right. So I'm going to start at the top, and I'm just going to go over the ones I want you to know. There are a handful of them that you do not have to know, just because we don't have time in order to go over every single one. The first one we'll learn about is an alkene. All right, so alkenes basically is something that has a double carbon-carbon bond. All right, so the way that you recognize an alkene, the functional group is a carbon with a double bond to another carbon. Okay, and then anytime that your book draws this where they don't actually show you anything here, okay, so if you look on your book, you notice that they don't have anything. In red, they have the double bond, but this kind of implies that at these spots over here you can either have other hydrogens or carbons. Okay, not in every case, but as I'll go through all the functional groups, I'll tell you. So, like the simplest alkene is called ethene, and again we will learn how to name these. It's a very systematic approach of how to name compounds. But that would be a simplest form. You could also have other carbon groups. You can have two, obviously you have to have a minimum of 2 carbons, but you can have 1,000 carbons. You can have 1,000,000,000,000 carbons. And if you have a double bond, it's the functional group, the classic compound is an alkene. You could have more than one alkene. Just to give you an example, you can have a cyclical compound, something like this, where you have 2 alkenes. Notice I have 2 of the double bonds in there. Okay. Now the next class is called an alkyne. All right. Alkyne is a triple bond. a triple CC bond. You'll hear me see this a lot, CC bonds. All right, just a carbon-carbon bond. So you have a carbon, tripled bond to another carbon, and then again, you can either have other types of hydrogens or carbons at that area. It really can't be anything other than a carbon and hydrogen. So you can't have alkyl halides. Remember the halides, the halogens, are on the 7A row: chlorine, fluorine, bromine, iodine. You can't have oxygens, nitrogens, phosphorus. It's really carbons and hydrogens. All right, so that classifies what a triple bond is. And the simplest form, again, just to give you an example, a real-life example, is this one. Obviously, it's a 2-carbon triple bond. This is called ethyne. That's how you name them. Notice the ending of the functional group is also the ending of how you name things. That's pretty much how you do it. This is also called acetylene. Acetylene is the common name. Most people know what acetylene is, and in torches and things like that. The next one, your book calls an arene. I'm going to call it an aromatic ring. So aromatic. Right? Aromatic is very specific. It looks like an alkene, but it's not. It's a 6-membered ring where you have alternating double and single bonds. Okay, this is actually called, benzene. Okay, but aromatic is the class of compounds, and we'll learn more about this in a later chapter about aromatic compounds. It has to be alternating. You have to have this. You have to have a double, then you have to have a single bond, then a double bond, then a single and a double, and it has to be in a ring. Right? These have to be ring structures. They can't be straight chain structures. Okay. This particular, like I said, is benzene. The way you read this might be confusing, but at every one of these points right here, there, every time that you see an angle on a molecule, that implies it has a carbon with the maximum amount of hydrogens on it. So I'll draw out what benzene actually looks like with the actual carbons and all the hydrogens. But as you can see, this takes a very long time to do. So for a shorthand, a quick way of doing it, they just draw it like that structure right there. But you can see this is really what benzene looks like with all its glory. Other ways of drawing benzene, which we will learn when we get to the aromatic chapter, is where they have a circle in the middle. That's maybe something you've seen in a biology book. These mean the same. This structure and this structure are the equivalent structure. All right, they mean the same thing. And this is what's meant by aromatic, is that the double bonds are actually being shared all the way around the whole entire ring. Okay, so through something called resonance. I'm giving you a lot of information right now of something that we will learn later, but again, I like to get the terms in your head so you kind of know what all this stuff implies. Okay, so we will learn about this later. I believe chapter 3 or 4, I can't remember right now, but we will learn about resonance.